Hi guys, it's Miss B. Today we're going to solve some equations and we're going to start with the first one. X plus 3 is equal to 7. So this one can be solved by inspection, which means by just looking we can see that a number that we need to add 3 to it to give us 7 is equal to 4. So we can see that x here is equal to 4. So that one is simple, isn't it? So now what I'm going to do, I'm going to show on the side how this equation can be solved by using flowchart. So that's for the beginning, that's okay because this one is simple, but it's going to be useful for more complex equations. So flowchart is pretty much, we're looking to draw some boxes, and in the first box we're going to put x. Then we're going to talk about what happened to x. As looking at this equation, we can see that 3 has been added to x. So I'm going to have another box, I'm going to say here plus 3. So x plus 3. So that's what happened to x. And then from here, I'm just going to put another box and put number 7 here. So pretty much what I'm saying here that x plus 3 is equal to 7. In order to solve this, so we're going to do something opposite. So we're going to go now backwards from this box to that box. And we're looking what has happened to x before. So x, we added 3 to x. Now we're going to do opposite or inverse, which is negative 3. So 7 take away 3 is equal to 4. And therefore, we can say that x is equal to 4, isn't it? Okay? Now, the other way of doing the same, to solve the same equation is this. X plus 3 is equal to 7. So we need to get rid of 3 because we want x by itself. So we want to have x by itself. How to do that? Plus 3, take away 3 is going to give us 0. So x is going to be by itself. So whatever you do on one side, you have to do the other side. So it's take away 3. So x plus 3 take away 3, it's gone, is equal to 0. So we can have that. Plus 0 is equal to 4. And then this 0 doesn't change anything. So we can just say x is equal to 4. Okay, so now we're going to move to another one. So I'm just going to move this up. So to another equation. So I'm just going to put here example, and the one that we're going to try to solve now is 2x plus 3 is equal to 7. So we can try to do this with the flowchart. So let's see, how actually this equation has been built. So we always start with x. X is there. What happened to x? 2, x has been multiplied by 2. Okay, so I'm just going to have another box here. And I say, okay, x has been multiplied by 2. So it's going to give me 2x. So we're going that way. Now, what's the next step? 3 has been added to x. So 3 has been added to x. Now we're going to go, okay, I'm just going to move. So, another one here. So 3 has been added to 2x plus 3. So then this expression becomes 2x plus 3. And now we do know that 2x plus 3 is equal to 7. So that's equal to 7. I'm just going to draw a few boxes here. And now in order to solve it, we're going to go opposite. So we're going to apply inverse operation of what has been done before. Inverse of plus 3 is negative 3. 7 take away 3 is 4. Again, we're going to do inverse. Inverse of multiplication is division. So now we divide by 2. So 4 divided by 2 is equal to 2. So therefore, solution is x equal to 2. So let's try to solve it now without flowchart. So 2x plus 3 is equal to 7. From the flowchart, we have realized that plus 3 was the last operation applied to x. So therefore, we have to do that first. I'm just going to try to change the color. So plus 3, take away 3. So this is not the best one. Okay, let's get rid of that first. Okay, here's the color. Yeah, oops. Just gonna. Okay, so let's try this one here. Plus 3, we need to get rid of 3. It's take away 3 on both sides. Take away 3. So you're going to have 2x plus 3 take away 3 is 0. So which we don't need here, nothing's going to change. 7 take away 3 is 4. Now we do have 2 x's and we need only 1 x. So what do we need to do is divide by 2, both sides. Cancel out 2's. 2 divided by 2 is 1. So we will be left with 1x. 1x is equal to 2. Voila. Solved. Another one. So, what about if you do one more? Okay, let's do another one. Okay, let's do one more. So, I'm going to have here negative 3x take away 5 is equal to 19. Flowchart first. Let's see what happened to x. X has been multiplied by negative 3. Going that way. Multiplied by negative 3. So that becomes negative 3x. Was the next step. So we took away negative 5 from negative 3x. So that has become negative 3x take away 5. Now we know that all this is equal to 19. Equal to 19. Yep. And now we want to solve it. How to solve it? We're just going to go backwards and apply inverse operation. What is the inverse of negative 5? It is positive 5. That's correct. 19 plus 5 is 24. What's the next step? So we're going this way, backwards. What is the inverse of time by negative 3? Divide by negative 3. 24 divided by negative 3 is negative 8. So therefore, x is equal to negative 8. Let's try to solve it here. So negative 3x take away 5 is equal 19. Looking at the flowchart, we know that negative 5 was the last operation that has happened to x. So what we're gonna do, we're gonna try to get rid of negative 5 by plus 5. Plus 5. Our try was really good because negative 5 plus 5, it's gone. We got rid of that. So what are we left with? It's negative 3x. Negative 5 plus 5 is 0. So that's fine. We don't need to write that one down. Is equal to 19 plus 5 is 24. What's the next step? We have negative 3x. How many x's do we need? Only 1. How are we going to get that? We have to divide by the coefficient that's in front of x, by the number that's in front of x, which is called coefficient. So it's negative 3 divided by negative 3, both sides. Negative 3 divided by negative 3 is 1, so therefore 1x is equal to 24 divided by negative 3 is negative 8. Hola, we have the same answer. I hope this was fun, and I'm going to record more complex equations in the next video. Bye!